All right, let's start, guys. We've waited enough. Can you hear me?
Yes, I can hear you, sir.
All right, perfect. So before we proceed, let me ask, um, has any of you who has watched those videos or who have not watched the videos? Because I'm expecting you guys to watch the videos. So are we saying we've watched the videos and I can ask you guys questions? Okay. I'm just going to call a random. Samuel, are you there?
Sir, he's coming. He's fixing his mouthpiece.
Okay. In the meantime, Abiodun, are you there?
Sir. Yes, I'm here. Can you hear me, sir? Yes, I'm here.
So Abiodun, what's the difference between IPv4 and IPv6?
Okay. They have they have uh, they have a couple of differences.
Okay.
Of course, the IPv4 has 32 bits, and
Okay.
IPv6 has 128 bits, and the IPv4 is octet, while the IPv6 is hextet, and also we resort to the IPv6 due to the growth of the internet connection. A lot of people so, and this results to the IPv6 help get much more IP numbers than the IPv4. And also the IPv6 is the routing efficient. It is routing efficient, and the security is maximized. I think that's all I can say for now.
Okay. Not bad. Before I proceed, Bamshima, I think you're there. Bamshima, are you there? Okay, Praise, are you there?
Yes, I am, sir.
Okay, you know the network system that is at the back? I think it is offline. Please let me turn it on.
Okay, sir.
I can't access it. Yeah, I need it to do some things. All right. So let me ask Shubandi. Shubandi, are you there? Shubandi, are you there? Okay. Dara, are you there?
Yes, I'm here. Yes, I'm here.
Okay, Dara.
Is it Dara or Dari?
Dari, rather.
Is it Dara or Dari?
She meant to call Dari.
Okay.
What is an update in an IPv4 address? Did you get
I
that?
think I'm not gotten there.
Okay, that's fine. That's fine. Samuel, are you there?
Yes, I'm here. Can you hear me?
Okay, so the question I asked Dari just now, do you know the answer to that?
Yes, an octet is one of those phone numbers on the IP, like 192, that's one octet. 168, that's another octet. Like one of those, each of those phone numbers, are an octet.
Okay, so each of the numbers before the dot,
Before the
each
dot
of the
here.
numbers before the dot, I know that. Yeah. Okay. So follow-up question for you, Samuel. How many bits is in an octet?
That's 32 bits. Oh, make that.
32.
I mean, 8 bits per octet. I mean,
It's 8 bits per octet,
yeah.
which sums up at the end of the day for 4 to
Yes.
the 32. Okay. Chris, you're raising your hand.
Yes, I wanted to ask if it is on now, you can check, sir.
Okay, let me confirm. I'm still not seeing it.
Oh, okay.
Is it showing the window screen? Once you just turn it on and it's showing the window screen, that's fine.
Okay.
Okay, so the reason why I shared you guys these videos is, remember I mentioned that I'm also going through the journey with you guys so that I can understand what you guys are learning from these videos, and I would know how best to come in. So upon watching the networking videos, aside from the theory aspect around the difference between OSI model and TCP, I think explaining some things when it comes to the theory part of IP addresses itself, I saw the need to dwell more, especially on submaxing and some other things when it comes to networking itself. So that's what I want us to do today. Praise, I think I now see it. Let me confirm if I now see it, if you can access it. Okay, for some reasons it is not coming up. Why are you not coming up? 1 minute. Let me try to access this with another route. Okay, while I try to sort that out, okay, so what's the difference? Let me ask, who should I ask? Let me ask Christian. Christian, what's the difference between the OSI model and the TCP IP model?
Where shall come again?
I said, what's the difference between the OSI model and the TCP/IP model?
Okay, the OSI model, can you hear me?
Yes, I hear you.
Okay, they contain 7 layers, while the TCP or IP IP model contains 4 layers.
Okay, can you list the layers of both of them?
Okay, for the OSI model, you have the application, you have the presentation, data link, section, transports, physical and probably network.
Okay, how about the TCP?
TCP is for, so I guess it should be application, transport, internet, then probably network access.
Hardware. Okay, okay. So in general, let me ask, is Shobande here now? Shobande, can you hear us? Okay. Dari, are you there?
Yes, I'm here.
Okay, so out of those 4 videos I shared on Slack, what did you learn? What was the new thing you learned about networking in terms of IP itself? Because those videos were just based on IP, submasking, and all of that. So, what did you learn?
Oh, thank you. So far, I what I learned so far is how to identify an IP address
Okay,
and subnet. So IP address and a subnet mask.
okay. So, how do you identify it? What the things you learned?
Okay. To identify an IP address, you have to go through the um, octet chart.
Okay, okay,
So from that octet chart, we can be able to identify the IP address and the subnet.
okay, okay, okay. Nice, nice. Samuel, you asked me a question around, I think if I remember correctly, around submasking, that or submasking that there are some things we understand yet. So from those videos, before I go into it fully, do you have some understanding now?
Yes, yes, I have an understanding now. Like at least to the point of how subnets are how wide they are existing actually. But the parts of this maybe this class and classless part of it. That's the only problem I still issue with now.
Okay, the class, like the class A, B, C, right?
Yes, class A, B, C, D.
Okay, okay, we'll touch that. We'll touch that today. Okay, let me ask Praise. Praise,
Hello,
are you
hello,
there?
sir. Yeah, I'm here.
Can you hear me? Okay, so
I can hear you, sir.
if you see a submax address of 255.255.255.0, what does that mean?
Yes. It means that. Please come again with question. The first thing you say, sir.
So if you see a submax address of
Okay.
255.255.255.0,
Okay. 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 It means is the normal that's the network address, but it hasn't been how should I put it? Because the explanation through the video that I try and understand is the normal for every IP address that is it starts with 192, like the networking the 192.168.1, and the host is the point zero at the back. So basically 255 and 25 okay, and changing it from to binary is always it will be 111, because it will be 11111, and the other will be 000. And then the so am I getting the question correct, sir?
Yeah, yeah, yeah. Proceed, proceed. I just want to get your understanding. So proceed.
Hello,
Um,
sir.
wait, Praise, continue.
Okay, sir.
Abel, you want to
So
say something? Abel, no way. When Praise is done, when Praise
Yes,
is
it's just a question when it's done.
okay. So Praise, proceed.
okay, sir. So after the I'm trying to I'm trying to remember everything again. Now after the
Mhm.
host, no, I don't know. Like after the also after that host 255.255.255 is it's still, it is still, it has not been but it has not been worked on or something. I don't know how to put it again.
Don't worry, it's fine. It's fine. It's fine. Don't worry.
Okay, sir.
You got to an extent. That's fine. Abel, you want to say something?
Yeah, thank you, sir. In the video, I learned about CEDA. which is I think is the slash notation, probably the short form for subnetting and max. So I don't really
as
understand
well.
the slash notation very well. Yeah, the slash notation. Yeah. I don't
Okay,
really get it properly, but thank you very much.
we'll touch the slash notation. Don't worry.
All right.
Okay. Sorry. Anybody with any other question before we dive into it? Okay. Yeah. So, all of Larry, you want to say something?
Yes, I want to ask one question about this router of a thing.
Okay.
Assuming we are setting up a router, is it possible for us to like to assign an IP address instead of the router giving automatic IP address?
Okay, good. Now, there was a mention between the difference between DHCP and static IP addressing. Who saw that in the video? Did you see that in the video? We'll talk about it better, right? And I think even in your course, there was mention of that. There's, however, pros and pros to having static IPs and having dynamic IPs. We'll talk to that properly soon, and I think I'll do practical examples with you guys as well today, which was the intention of all of this. So let me get to it. 1 minute. Can we hear me and can we see my screen?
Yes, sir.
Yes, we can hear you. Okay.
All right. So we'll be using two different running networks for me to walk through this with you guys, so that you guys understand this subnetting properly, IP configuration properly, including the documentation. So I wanted to ensure that you guys have basic understanding before I even go into things, so that you would understand the basics. So when I'm doing this whole walkthrough with physical networking setup with you, you get to understand things better. Now, from the videos that were sent, right, from this alone, from this, let me see if I can zoom this in. From this IP, let's leave the submask alone. Let's leave the submask configuration alone now. Now, for this IP configuration, 192.168.1.0. From here, we know that the 192.168 here is the network part of this IP. It is the network configuration of the IP. Then we have the 0 being the host part. Am I correct?
Yes.
So now, this host part is for your devices. It's for all of your devices. And for this particular host, or this particular device, or this particular IP, we will remember that from 0 to 255, as in total, that means that's 0 is a host, 255 is a host. 0 is meant for management, likewise 255 meant for management. So it means those two IPs are not usable. And I think you should have gotten that from the first videos. So you can't use 0, neither can you assign 255 to someone. Now, that's one. Then the slash notation of 24 determines the submask. Now, for this particular submasking configuration, this means 255.255.255.0. That is what this means with this slash 24. And do you know why that is? Remember, this is mostly to you, Biodun, you asked the question. Remember you mentioned that IPv4 has 32 bits in terms of the IP configuration based on the octets.
Yes.
Now, in each of those 32 bits, it is 8 bits per octet. And since it is 8 bits, if you had 8 plus 8 plus 8, that's what will give you 24.
24.
So this 4/24 is the bit in terms of where you're trying to configure the submask configuration. So
Okay.
it's pretty much, you just have to understand, and you can have different configuration. So that's why the CDAD slash notation is easier
Sorry.
to
Okay.
configure compared to
Sorry.
you having to write. Okay,
Sorry.
Dario, you want to say something?
Yes, please. Can you come back again in that aspect, please?
All right. Okay, good. Now let's do practical example because that's why
Okay.
it is like that. Can I do a practical example here? Okay, I think I have to do it here. Okay, you know what? Okay, give me a minute. Let me join the system downstairs. There are
Okay.
some things I want to show you that to show you here. 1 minute.
Okay.
Okay, can you hear me? This is Jet.
Yes, we can, sir.
Okay, all right. Let me share my screen. Just share the entire screen. Okay. Now, from here, let me open command prompt first. ipconfig. So from our ipconfig, yes, this is, so I'm currently using Ethernet on this system. And on this Ethernet, we can see that the IPv4 address here, can we see it? Is 192.168.1.136. Can we see that?
Yes, we can.
Now, you can also see that the submask address for this is 255.255.255.0, right?
Yes.
This is
Yeah.
what said the submask configuration is using /24. Because remember, we said and we know that this whole address here is 32 bits. And each of these octets, example, the 192, the 168 is 8 bits each. So 8 bits here plus 8 bits here plus 8 bits here equals to 24. So when you have this, I think that configuration should be here, networks. Now, when you have this, you see 192.168.1.0/24. So it's saying, oh, in this particular submask configuration, we are using the 255.255.255.0.
That's 0.
Did you get that now?
Yes.
Now, this is for this configuration. If we do /25/8/8/16, what does that mean? If it is /8, it means the submask configuration is going to be 255.0.0.0. If we do /16, it means it's going to be 255.255.0.0. Did you understand that?
Yes, sir.
Yes.
Good. Now, Samuel, you asked the question the other time. Okay, wait, please.
Yes, sir. So I got lost in that part about the 16 bits again. Are you saying after the 2.55 to the 3 bits, that's 24? When it comes
No.
to it is okay.
Now, we understand that an IPv4 address, example, which is this,
Yes.
and even this has 32 bits.
Yes.
And
Yes.
we know that an IPv4 address starts from 0.0.0.0 to 255.255.255.255, which is what
Yes.
gives us a total of, I think, 4.6 billion addresses. Is it
Yes.
billion or million addresses, right?
Yes.
Now,
Yes.
so we understand that for each of these address before the dots, one of it is an octet. And in that
Yes.
octet, one octet has 8 bits.
8. Okay.
Because this whole thing here is 32 bits. How
Okay.
is it 32 bits? 8
8 times 4.
plus 8 plus 8 plus 8 gives us the 32 bits.
Okay.
Now, from the submasking configuration, you know, I think I can do. Yes, this is better. Let me move this one down here. Now, we understand that when it comes to using the slash notation, I mentioned that this 24 is just the addition of the total bits you want for that submask configuration. So in this case that it has /24, you can see that our submask address is 255.255.255.0 because 24 is 8 plus 8 plus 8, which gives us 24 and gives us
Okay.
this submask configuration. Now,
Okay.
it means if you want to have /8 here, if you write a documentation of /8, for example, let's create this and see tests. This is not going to go because of this particular network, but I'm going to show you how it's going to go later on. So let's just say test network. And we say our gateway. Can I even create it? Okay, let's say our VLAN is 2. Let's just call that for now and click on add. Can I edit it? Nah. Okay, this will not do. This will not do what we want, but let's just write an example here. So if we write 192.168.0.0/16, who knows what this will give us in terms of the submat address?
255.255.0.0.
Who answered that?
Praise.
Who
Hello,
answered
sir.
it? Who said it? Who said it?
Praise.
Who said that?
Yes, I am the
Praise.
one, sir. Yes, sir.
Okay, that's correct. Now, what if I do /8 here? What will the submask address give us?
/8 should be 255.0.0.0.
Okay, good. Now that is correct. But if I write this like this, it will fail. Who knows why it will fail?
Because you did not remove the 1.68.
Exactly. So submasking is simple. It went successfully here because this did not allow us to do the configuration of submask and all of that is why it's successful here, right? So this, if you write it, I think we'll test it upstairs later. This will fail if you wrote 192.168. Now, Samuel, this is where your question came in. Your question was, what's the difference between class A, class B, class C submasking? Am I correct?
Yes, sir.
Now, class A is when you use the 8-bit slash notation. So if this was 198.0.0.8, this will give you the class A. And the class A has, I think, is this 60 million IPs that you can reassign, right? While class B is lesser and class C is lesser. So anything class A is the /8 dot notation when it comes to using that CIDR for it, which gives us 255.0.0.0. /B is when you use the 16. So when you use the 16, it gives you class B of something lesser than the IP assignable for class A. So this current server that we are on, okay, I'm going to ask that question later. Then when you have, say, 1/24 here is /C. So anything from here, 24, 25, whatever the case might be, falls under class C. Did you get that now?
Yes, sir.
Okay.
Okay.
So now, when it comes to this submask address, who knows the class this falls under? 255.255.255. What class does it fall under?
See?
Class A.
Exactly. So submasking is easy, is sweet, but if you don't understand it, which I felt, these videos that you guys watched did not actually capture that understanding well. It only explained the theoretical aspect of how the bits calculation is in binary, how what an octet is. That was just what it explained. How to do the configuration, it didn't actually go through it, is why I wanted us to go through it together today. Now, let's use this address here. Let's use this address here. This particular address, what class does this submask fall under?
That's B.
Class B.
Why is it class B?
Yeah. Okay, 240.
It's class has B because there is no
So I
objective.
think
240. 1, 2, 3. Let's 1, 2, 3.
it's
No.
Class B is not up to 255.
It's still under class B.
Okay, why were you guys not sure? You guys were correct. It's class B because the only thing that we're certain of that the network is having is this first two octets, 255.255. So every other thing from here is assignable to the host. There's, however, something here that needs to be mentioned. Now, if you see something like this, it means it is not using the static 8, 16, 24 configuration. Now we understand, you know, in your in those videos I sent to you, there were ones that the IP configuration was saying /25 /26. Do you remember? Do you guys remember that?
Yes, sir.
Okay, now what that does is you are borrowing a bit out of the next one. So while this is in class B, right, is in class B, is not the full, you're not having the full IP assignable to that class B for this configuration alone. You are having, you've borrowed, okay, 240, that calculation should be, I think you've borrowed you borrowed 2 bits from the class C for your configuration. I'm going to show you those ones better when I get back upstairs, because there's a predefined rule to how you can add and how you can remove. Unless if you look at those calculations, I think in the second video there was, if you just borrow one and you want to configure it into like 3 different people, it's not going to work. So we'll do that one much more later, don't worry. So let me leave this one. Let me delete this.
Everything will give you 255.
Okay, so now.
So that means this two. Sorry, sir.
I can't hear you. Who's talking? Okay, so does anybody have any questions? Or what we've done so far? Any question? Any question? May I have a question? Okay, now since there are no questions, okay, Samuel.
Okay, so I get the class, that's classic class B part now. But you explained the other time with I guess this one I took once it's a private IP, right? But when you are saying 192 once is 8.0.0 then slash, let's say, okay, 192.0.0.0 then /8, that's for class A. I'm not thinking that, is that not like a private, it's not like a private IP, it's not like classes are meant for public. They are not right.
Oh, okay. So number one, when you want to use the /8, which will give you 255.0.0.0, that is a class A IP itself, right? That's class A subnetting. Class B is 255.255.0.0. So now when it comes to the classing, it doesn't matter whether it is private, it is public, or it is even local. Now, who knows? Okay, who knows the difference between class private, public, and local IP? Okay.
I think, okay,
Somewhere I thought don't try.
I think local IP is like for like local network 192.168, right? I think public is the IP. Okay, IP address is, I don't know, is it accessible? And private is like owned by companies. So
Okay, so private an example of private IP is this 192.168, which is just available in a particular network, in a particular. Okay, now let's take it from the level of internet itself. Okay, this will not show it. This will not show it. So if this was Starlink, Starlink will give us a public IP. So if Starlink gives us a public IP that we are using for our own system, our own network infrastructure is going to be using a private IP. So it means all the devices connected there are on that private IP. Now, each device connected to that private IP has its own local IP. Now, if you are aware of this, your local IP address is 127.0.0.1 or whatever the slash notation is. So that is different from 192.168.0.0. Do you understand the difference there now?
Yeah, yes.
Now, any of this type of IP, either it is private, either it is public, either it is local, can either be divided into class A, class B, or class C based on your need. So class A, class B, class C is not just for private or public IPs alone. It is for any IP in the any IPv4 address. Did you get that now?
Yes, sir.
Okay. Now, any other question before we proceed? Okay. Since there are no questions, this particular local server configuration is limited. So let me move back upstairs to show you something more. Okay, can we hear me?
Yes, we can hear you.
Perfect. I think maybe the network is better now, but this screen like this. Okay, network restored. Now, we can see there's a difference between the first network server I showed you, or the network configuration I showed you, and this new one here. So in this one, we can see that this network is divided into 4 different networks. And these 4 different networks are running with their own separate submast or subnetting configuration, right? Now, let me ask David, for these different networks that I are seeing here, what do you understand from this alone first? Let me just get one thing first.
So from which network? Sorry.
Any of them, pick any of them and just tell me what you understand. You would see that there's a difference between this one is not using 192. So now, what do you understand from here?
So I did see the network, like, yeah, like maybe she use your.
There's a subnetting configuration here already. Can you see my screen?
Yes, I can see
What
the
is the
screen.
subnetting configuration? So I'm not going to point my screen to where the subnetting configuration is. So you tell me, okay, where this, what is this doing in general?
The like the difference between Sir, please can you say the question again? I didn't really get.
Okay, so it's not really a question yet. I just want you to tell me what you understand from what you are seeing on the screen as of now.
Okay.
What do you understand?
On the list here that we have routers, we have subnets, we have IP address, and their sizes, their pool sizes.
Okay. Is that all?
And the other side we have available maybe space or capacity that each IP address can carry. I don't know.
Okay, that's fine. That's fine. Samuel.
So,
Okay, so from what you're seeing on the screen, what do you understand?
okay, I noticed there's 5 different sections. of IP addresses. So I think it's that same, let's say the same company, but they are categorized whereby they are divided into the styles, students. So each group has its own subnet. So like this campus staff now has IP address of 10.0.220.0. So and it's different from the subnet of the students, different from subnet of Crystal, and that's also the IPv6. I think these are the number of IP addresses that are available. I mean that are in use currently on that subnet.
Okay, now this is where I
Hello, sir.
yeah, David.
Okay, on under the subnet, we have those IP addresses with different classes.
Okay, okay, okay.
Under the
What
first under the first router IP address falls under first class, which class A. Right, the second one is no. What is hello, sir.
okay? Did you get? Is there anything else you think?
Just different IP address from the different routers.
Okay. Okay. Now, first, all of this network configuration here are using class C. And the reason why they are using class C is you would notice that I think we mentioned that class A is 24 bits, right? And like the old host, which will give you 244.0.0.0, and it will give you available host of I think 60 million plus. And the reason why it gives you the available of 15 million plus is only this place is available for the network. Every other thing from here is available for hosts. Okay, I think I won't be clicking because when I click it, it opens it. So only here is. Oh, I think I should have documentation. Oh, I won't see it there. I should have the documentation here. Okay. A minute. Where is the documentation? And this one. I can't find that guy. But from here, everything here is in class C because they are all using /24. So it means even for this default, the only thing that is available for the host or the devices connected is this last one. So every other thing here, no matter what it is, even if it is 0 that it is written here, it shows, oh, only here, 10.0.0 here is for the network. Only the last 0 here is for host. Same thing applies to this. 10.0.10.0 is for the network. So what this is doing is we are breaking the class B of the class B subnetting into multiple class C. Did you get that? And can you see how that is done?
Sir, please come again.
Okay. All right. Let me look for a different analogy. Now, when it comes to private IPs, let me change this one back to. When it comes to private IPs, the ones everybody is familiar with, the IP everybody is familiar with is 192.168.0.0. That's what everybody is familiar with. Now, aside from that, we also have 10.0.0.0, and we have, I think, 172. Let me confirm that. 1 minute. Let me just confirm the place that thing is written. Yes. So, okay. So when it comes to class A IPs, for example, this particular IP we are using here, 10.0.0.0, is mostly seen for class A because you are saying, oh, make everything here available. However, this one is not class A because we are using the dot version of 24. And remember, 24 is going to reserve the first 3 years for the network and 0 year for the hosts. So because we have 4/24 on everything here, it means this particular IP, this first one, if you see the range here, the range is from 10.0.0.0.6 to 255.4. Remember, 2554. 2555 is reserved, and the 0 itself is reserved. But in this particular network configuration, not only 0 is reserved, 0 to 5 years is reserved. Is why just 6 to 255 is what is available for hosts. So you would see that in this second network, it is using 10.0.10 as the network itself. Why the .0 is the host, which is why for the range, you are seeing 10.0.10.6 to 10.0.10.254. So if anybody connects to this network, they are going to be assigned an IP within the range of 10.0.10.6 to 10.0.10.254. Did you get that?
Yes, sir.
Now, if this was, I'm not going to do it, so I don't want to play around with a network server that is currently active. Now, if this host address here was 10.0.0.0. Now, you can see that this one, so if you use that 24 years, it's not going to work. But if this was /8, okay, it is now available for auto scaling here. So let's say even the thing should be. This will not work because of the other one. So that is other servers where they have. This will not work. This will not work. This will not work. I think we have to use 1.16. So let's see .16 or .1. This will not work because this has been configured to use. So only 24 is going to be available for us. Only 24 is going to be available for us. That 24, we have to make it work with the host. So this one can be, it's 50. So 24. So this is one that will work here. Okay, let's see. Let's try something else. Let's try something else. So this was what I wanted to show you before that that server will not do, because this one here is mostly, it has the configuration to ensure what you are putting in is correct. So if you put in something wrong here, it's not going to work. And the reason why this is not working here is because other networks are already here. Other networks are already here that are using the class C configuration. So you cannot move from class C that has been configured for other networks to class B or even class A. Did you get that? So if you want to create as much as possible network now, remember from this, we are splitting the class C network, which Class C network will give us around 60, I think 65,000 IP addresses. So instead of everything being on one address or on one network, we are splitting it into multiple networks in such a way that each of these networks would have their own allocated or assignable IPs. So if they are connected to the management IP or network, and staff has an issue, the network here would not have any issue, and it will be because the IP address that are available there is totally different from here. And we can see that in action if we go to devices. If we go to devices, let me just filter with people online. Okay, good. Now, let's use this person, for example. This person is on the student network. If we look at the IP that is assigned to this person, the IP address is 10.0.30.149, which falls under the network of the student. And if we look at this one who's on staff, you see the IP address addressed to this person is 10.0.20.204. So we've divided the whole network in class B into smaller chunks of class C networks. Now, we can also say we should have a class, we should divide, let's test that. Wait, before I test that, do you guys understand what I've said so far?
Hasa, well, I know, I don't understand very well.
Away. Okay.
And my own question is, you only talked about the IP4, and what about the IPv6?
Okay, so we'll handle IPv6 later. Let's focus on IPv4 now, because if you don't even understand IPv4 well yet, to understand IPv6 is going to be much more difficult. Yeah, who's that?
Yeah, I'm trying to get the part where you said this particular network you are showing us is class B, and it is, let me say, downgraded to class C or subnetted to class C, right?
Mm-hmm.
Okay, that's just the point I want to understand.
Okay. Who is that?
Hey, Samuel, I want to just confirm something. I was thinking those classes are, let's say, they are assigned based on, like, is it possible, like, can we assign classes to ourselves? I mean, I think it's okay. Let's say there's this IANA, it assigns like classes to different, let's say, to companies, assign classes to companies or something. Can we like assign classes? Like this when you're doing practical here, you're saying everybody's on class C. I can't downgrade them anymore.
Okay.
So I was not thinking that, is it possible that they should be on class C without just going to class C or something?
Now, the IANA, what they would give you is a particular class of IP. So if you want the class A IP, remember these IPs themselves. Okay, let me clear this off so we don't have ready. Remember that these IPs themselves, there's a way you calculate them in bits for it to be correct. So if you just wrote okay, perfect. Yes, let me give an example of that. Now, when it comes to class BIP, I think that starts with 172.16. Yes, yes, the 16.0.0. I think that's where class BIP starts. That's also start from. I think they should be one. Yes, I'm correct. Yes. Now, class BIP, if you are assigned class BIP in general, if that is what you have in general, is going to only give you total usable IPs of 65,489. That is that. Class A starts from, I think that should be 10.0.0.0. And for that one, we're having /8, but this one is not available to scale on this platform. So if this was 8, it will give you the full class A. Now, as you can see, in this case, class A is not available. So we can't use the full class A, but we can use the class B. So class B will give us class B is 172 dot like a standard class B address .0.0/16. So because 0 is taken, that's why we used to use 1 here. Now, this would, you can even say like the broadcast IP. Thank God, this is even very detailed. You see that the broadcast IP, which is the last reserved IP, is taken, which is 172.16.255.255, is taken for broadcast. The gateway IP is 172.16.0.1. Then the default configuration IP is 172.16.0.0. Now, in this case here, we would have the full 65,489 IPs, which is what we have for this whole network here. Which is what we have for this whole network. So we have a full class B IP access or IP allowable IPs, which will give us the full total of the 64,000 assignable IPs. Now, what we want to do is we don't want to have the whole network use just that class B, because if everything is shouting and broadcasting to each other, it will slow down the network, right? Did you guys remember that part in the video?
Yes.
Now, which is why we now divided that class B IPs that we have into smaller class C IPs. Did you get that now, Samuel?
Yes, sir. Yes, I get it now.
Because we can have a total of 64 assignable IPs, and we don't want to have them on just one particular network, is why we are now saying, let's create multiple class C IPs. Since we have the allocation itself for our network as class B, if we had the allocation of our network itself as class A, it means we can create multiple class B networks inside it. Did you get that, Samuel?
Yes, sir. Get.
Perfect. Now, Daryl, somebody asked the two questions you guys asked first. I skipped my mind. Daryl, you guys will ask your question again.
You've answered the question already.
Okay.
I wanted to, yes, I wanted to ask about this.
Okay, then. Now, I wanted to create.
So, sorry. Hello.
Okay, who is that?
This Dari.
Okay, yeah, Daryl, yeah. Ask your question.
Yeah. This subnet here, from the default, it falls under class A. Am I right?
This subnet.
This default subnet.
Default subnet
Yes.
is not in class A. It's not in class A. This default subnet here is in class C, because we're having the /24. If this was /8, that means it's in class A. So no matter what is written here, this IP configuration, this whole IP here, is for class A. But no matter what is written here, it means 10.0.0 is the network, and since this is the network IP, it falls under class C.
Okay.
Now, did you let me first understand? Did you understand it now?
The reason why I asked that question is this from 1 to 26. So that's why I said does it fall under class A? But since you said there is this /24.
What do you mean 1 to 26? Let me first understand that. What do you mean by 1 to 26? Or you mean 1 to 6?
According to the videos we watched,
Mm-hmm.
under class A, and
Mm-hmm.
first octet address, that is 1 to 126.
No. 1 to 26K. There's no 26.
One
The full
to
address is
126, not 26. 126.
okay.
1 to 126.
192. What you're saying is 192 to 1, it's not even 126, it's 192 to 168. So that's what I was trying to understand. What do you mean by it? It's 192 to 168.
I think I'm a bit confused here.
Okay.
I think what I'm also seeing here in the video we watched, it says class A.
Mm-hmm.
The first octet address for class A ranges from 1 to 126. And
Okay.
for class B, the first octet address ranges from 128 to 191. That is, when you see an IP address, you can easily tell if this is class A or class B with
Class
the
A.
yeah, exactly. That's why he was asking if, because in the video you are showing us now, it is 10.
Mm-hmm.
The IP address is 10
Mm-hmm.
point something. So it ranges from 1 to 126, which falls under class A. That was why he's asking. But since you said it has the /4, which for the subnet, it doesn't mean in as much as it has the /4, which is the sub.
Okay, I think what you guys are saying, like how to identify a particular IP address when you see it.
Exactly.
Now, remember, I mentioned this network here is on a private is on the private network itself. So this is not the network coming from Starlink itself. Now let's look at Starlink.
Okay.
Let's see the IP address from Starlink. Let's look at the IP address coming from Starlink. Can I see that? 1 minute. Let's see if I can see that. Okay, good. What is coming from Starlink as the IP address is 100.106.217.240. With this, will you say this is a class A or class B IP?
Class A, according to the.
I will still say it's class A because the first octet address is 100.
Exactly.
The first octet address is 100, and in class A, the first octet address is 1 to 126. So it's still falling into class A.
Exactly. Now, you can see that it is, and between here too, right? In the network here. You see that in the network here too, this still falls on 10, which still falls on the class A, right? But because of the network configuration on this particular machine, we can't give one network everything to be class A. It's why we had to use the class B. Did you get that? So using the IP address, yes, you are correct that it is a class A IP. But when it comes to the subnetting configuration itself, what is going to be assigning to people is the class C IP. Because we're having a subnet configuration of /24 and not /8. So it is not giving you a range of 10.0 to 10.255.255.255, which will have been a class A. Did you get that? So because there's the subnetting of version
Yes, sir.
24, it makes this whole IP here, even if 10 fall under class A, to fall under class C for this whole network itself. That is why it was divided like that. Now, wait, somebody was raising hand. Who is raising hand?
Yes,
Harry.
yes, I'm the one. So with your explanation now, that /24 is the one that makes it falls under class C,
Exactly.
isn't it?
Yes.
Okay.
Now let's do something else. Let's do something else. Let's create a let's divide a class C into 4.
Maybe. Yes, sir.
Okay.
Are we saying that let me use this English, probably we break the network down, right, to class C.
Exactly, to class C. So we broke the network that entered into class C, is what I think.
Okay. So yeah,
And now we really want to now break another network down into we want to break a class C network into 4 different subnets. Now to do that, our host name, so I think we have, let me confirm something. We have 40, right, as class B, as class C. So let's break it down. 1 minute, please. Give me a minute. All right. But now we want to break a class C into 4. And to do that, so we already have 40, right? So let's have new virtual LAN, and we'll call that 10 dot, okay, 10.0.50.1. But instead of /24, we want to borrow 2 bits. So if we are borrowing 2 bits, it's going to be 26. Now, let's call this class C subnet A or subnet 1. Class C subnet 1. Now, what we are doing here now, we are borrowing 2 bits from the class C itself, which is supposed to be, class C is supposed to give us 250 something IPs. I think is that 257 in total, plus the 0 and 256 plus the 0 and 255. But what this is doing now is we are now dividing a subnet of C. We are subdividing it into and dividing it into 4 different networks. So if we are dividing into 4 different networks, which was what I was trying to show you guys downstairs before, that the 190, I think we saw 2 or something, I can't remember that number, has a meaning. It's because that network has been divided, it has been subdivided. So if we create this now, this will create a particular subnetwork of class C. You can see this as created, and we only have 61 assignable IP and the full size of 61. Now, if we want to create the second network or the second subnet of this class C, it's going to be, let's call it class C subnet 2. Class C subnet 2. So that's going to be, okay, who can tell me the IP? Don't let me write it. Who will tell me the IP?
10.0.50 and
10.0. I'm not hearing
60, 50.
Oh yeah, one break that is 48. That is 48, Abby. Because the first one we use is 50. So it should be, since we're breaking it down, it should be,
No, that was
48.
some
Oh, sorry.
the 50.60 something.
Let me take it back. Let me take it back quickly. Right? Let me now. This has given us. This is what we're using. We're dividing this class C of 10.0.50 into 4 different subnets. So if we're dividing into 4 different subnets, the first one we've created has given us a range of 2 to 64. To 62 rather. So the next one we want to create, what is it going to be? That's what I'm asking now. So what is this IP here supposed to be?
It should be 10.0 dot 60. No. 10.64. What's next? Then 0.0. No, then it should be 0.0, right?
0.0, yes.
I can't really remember the.
It's 26.
So no, slash. You can start this field.
No,
one.
So now, okay, now hold on.
Slash 27.
No, it's not 27.
No, 28 rather.
No, 26. It's 26.
It's not. It is still 26. Yeah, wait. Let me. Can you guys hear me?
Yes, we can hear you.
All right. Now, we want look at this division we did here. This first 5 division. All we divided literally is 10.0, and we divided it into this different network itself under class B. And if we're dividing it into class B, multiple class B, it means everything here is 24. So now we want to divide a class C into 4 different networks. We want to divide just one class C that is supposed to give us 255 into multiple subnets, and we want it to have
16.
If we have
16, yeah.
Diary, you guys are not listening. You muted your mind, but you guys will still not be listening. If I now ask you a question, you say this. Now, if we want to divide it into 4, we have 8 bits in total in that particular class C, or the last class, right? 255.255.255.0. So we want to divide that last one into 4. It has 8 bits in total. So if I divide into 4, we should have 2. We should borrow 2 bits each. So since we've used the first one here, which has given us from the range of 2 to 64, the next one is going to be on that same configuration, which is the host configuration now, which is 10.0.50. That will be 64/26. Okay, 24 should be the main stuff itself. So this one should be 25. Yes. So 24 is where it started from. Is where the orange is starting from to 126. So because of that, it means our host, which is this host itself, is going to be 10.50.65. Remember, when it was at the default 2, our host was 1 out of that usable IP. So host will take its own. The core 0 will take its own. 255, which is the last one, will take its own. So this now has been divided into 2. This class C subnet itself has been divided into 2, and we're going to 4. So this is class C subnet 2. Did you get it?
Yes, sir.
Samuel, let me ask you now, because you were interested in subnet. Now, we are dividing this class C into 4 different subnets, right? So what is going to be our next configuration for this?
Okay.
Our next IP range for the subnet 3.
The next one should be 10.0.50. 128. 128 to calculator.
128, 26.
Oh, 129. 29.
Exactly. So you can see this cannot be your network or your broadcast address. 0, the default is the network, the 25 is 255 is the broadcast. You can see we now have an IP range of from 130 to 190. So this becomes class C, subnet 3. Okay, now who should I ask the last one? Bamshima, are you there?
What's in that role? What's in that role?
Barry, you want to say something?
Yes. Please, I just want to ask for clarification. This 64 thing and then this 128 of it. How do we get it?
I'm not hearing you, Dario.
Sorry. I just want a clarification about this 64 and 128 of 18. How do we come up with this 64? Yes. This class subnet 2 and class subnet 3. So how do we arrive at that 64 and 128?
How do Okay. Since one of the students actually got it, Samuel, do you want to explain that? Let me see. Maybe your explanation will be more different.
Okay, I will go 64, right?
Mm-hmm.
Okay, and since we are dividing the subnets into 4 subnets, and the range of IP address is 255, and 0 to 255 IP addresses, that's 56 IP addresses, and I divide to 4 parts. So we have to do 56 divided by 4. We have to get 64. Can you hear me?
Yes, we can hear you now.
Now, okay. So I was saying, since we have 255 like as the octets in the IP address, and 0 to 255, that means 256 IP addresses. And we're dividing into 4 subnets. That will be 256 divided by 4. We get 64. So for each subnet, since we're dividing by 4, will be 64. Like so, 64 plus 64, you get 128. Then 128 plus 64, you get the next two. You get. You understand?
You did get it.
264 divided by 4, so it's give us 64, right? So
No, wait, this is it.
okay,
So this is it. Let me start from the beginning. Thank you, Samuel. Actually, that's the simple answer. So remember that we from our octets, each octet has 255. 255 so it's from 0 to 255. And we know that the IP assignable is from that 0 itself is assignable to the network, 255 is assignable to the host. So the total IPs in that particular class C configuration or in a particular octet is 256. So if you are dividing your network into 4, into 8, into anything, you divide that 256, which is the total assignable IP in that particular octet, divided by the total number of subnets you want. So in this case, we are creating a subnet of 4. We are creating a class. It's literally a class D subnet.
1, 2, 3. So the next
4
one
subnet is like class C. So it means we will divide 256 by 4. And if we divide it by 4, the first value is 64. So if you want to get your next range, it is going to be 64 times 2, which will give us 128. Then your next range is going to be 128 plus 64. So you have to add 64 per each range you want to have. Did you get it now?
Yes, but you know, when adding the number, when you were adding the number, the first one you wanted to add 64, but it shows it's not correct. So you added 65. The second one too,
Now,
you also add 29.
okay, good. Now, look at
And
this.
also, okay,
Hold on. This is the host address we are setting.
yes.
This is not the network address. So the network address starts from that 64 to 120. I think that should be 127. 127 what? Let me confirm. Okay, let me even show you here. Okay, we're using 65 example. So let's use it here. Good. So you see the network range. The network range itself is from 64 to 127. That is the network range. So in this place, we are entering our host address. Our host address cannot be the network nor the broadcast IP. Remember, the broadcast IP is the last IP in that range. And the first IP in that range is for the network. So in this case, if we do 64 here, it will not go because 64 is the network address. And if we do 127, 127 will also not go because 127 is the broadcast address.
I see. Okay.
Did you get it now?
Yes.
So that is why we added one more for this one to be 65. To be 65.
Okay.
So the gateway IP, which is the host address itself, is 10.0.50.65, and the host itself, the network address itself, is starting from 64. So the configuration is from 64 to 127.
Okay. All right.
Okay,
All right.
now.
Thank you. Well, one more thing. Why is the 50 there constant? Why is the 50 there constant? You know, 10.0.50.
Now, remember what we are dividing. This subnet
Okay, just one subnet.
Is a class C subnet into 4 different subnets.
Okay.
So in this case, this last class C here is on 40. That's the address we put it on, is on 40. So what we are dividing here is this same class C, is what we are dividing into smaller chunks.
Okay. All right, just clear now.
Who is reading now? Christian.
So okay, now let's say you want to further divide the class C subnet into another the class, you want to divide it into 4 subnets now. So now, since we've got saying that the one for 10.0.5, 10.0.50.128, the next one is going to be 10.0.50. Okay. Point 50. What's going to be the IP? Okay, I'm saying since you said you're going to multiply it by 2, is it going to be the next one? Is it going to be 255?
So when you divided it into 4,
I don't
the assignable IP on each of these subnets is supposed to be 64, right? So your next subnet configuration is going to be plus 64. The reason why I said times 2 is the second one is just 64 plus 64 is the same thing as 64 times 2. So it's supposed to be 64 plus 64. The next one plus 64, which is how we got 128. Then the next one as well is plus 64.
Okay. So if you're to add 64 to the next, you're going to get 192. But the 192 is not going to... So it's now be 193 over 26.
Exactly. So you now see our
Extra
gateway
network
IP is
faster.
3, and if we add, so let's call this class C subnet 4. Perfect. You see that we've now divided just one class C network into 4 subnetworks. So if anybody connects to this particular network here, the IP that is going to be assignable to them is from this 2 to 62. They would not get from this one. So it means if you're on this network and your network here is bad, it won't affect you here, even if you're on the same class C or the parent network. But because you have been divided into your own subnetwork, you are on your own. Did you get that?
Yes, sir, we get what you're saying. So,
Perfect.
like what you're saying now is, for example, now let's get realistic now. This is exactly what's happening in like this ICT hub now. So let's say cloud computing students, you're connected to the class C network, and let's say everyone comes for the class and there's traffic. So people connected to the third subnet, let's say there are people from data analysis, so they won't experience the same network issues as us in the other one, right? That's what you're saying in summary.
Exactly.
Okay, sir.
Samuel, your hand is up.
Yes. What was that? I don't know if it's related to this, but okay. Is there, can we, like, when we are creating the subnet, is it possible? Because I don't understand how we are borrowing bits or something. Can we, like, this not each of these 26, can we put like 27 or 28 or something? I don't really get that part. How are we borrowing bits?
All right. Now, let's do for 27. 1 minute, please.
Yes, I can hear you.
Okay. So I need to wrap this up as soon as possible. But what I will do first is I'm going to share you guys a video that shows you that details or explain better how to actually borrow bits from the next one. So like what we did here now, we have a class C itself and we're borrowing bits from the last octa is what we did. So but before then, I think we can let's do another one that will split into 8. Let's split into 8. So if we want to split into 8, we are going to be borrowing, I think that will be 3 bits. If I remember correctly, we should be borrowing 3 bits. If we're borrowing 3 bits, that will give us on /27. So 27 is 24 from the class C, which is 8 plus 8 plus 8 on the first 3 octets. Then we're borrowing 3 from the last octet, which is 24, 25, 26, 27. Yes. I be able.
Yes, please, before we proceed,
Mhm.
in the first class we just did, in the first class, in the class C subnet 1, we have 2 to 62, and in the subnet 2 we have 66 to 126. That's the range. So here now, the 0 and 1 is not there.
The 0.
Yes, and
Are you
then
talking about the 0? It's supposed to be in this.
it should be probably from 1 or probably from 0 to 62, and from
Okay.
66 to.
So the reason why, yes, that's correct. So the reason why we are not seeing 0 here, and this one is not ending at 64 because this is supposed to be 64, right? You're only having an available pool of 61, is because this particular system is using one particular IP. is it one? Yeah, it's using one. It's reserving one for its own internal use. So we have the network taking one. We have the host name taking one. We have the
Okay.
broadcast taking one.
Okay.
So if you add three together, that becomes 61 plus 3, 64. So in that case is why the remaining available IP is 61.
Uh-huh. Okay.
So that is why zero here is not in use, because zero is being used by network, right? One is the host name, 64 is the broadcast, and the 63 is being reserved for this network management within this particular system.
All right. Does that apply to subnet 2 as well?
Yes, that is how every other subnet here. But if you are using it above as outside of this system, what you are going to be having is 62 pool size, because aside from the host, the gateway, and the broadcast, every other IPs are going to be assignable.
Okay. All right.
Somebody else is that. Who else is that? Who is raising hand?
That was the question he asked. I was like, I have an idea of it, like the first gateway of this, and that's what I wanted to mention. You've already answered the question. I wanted to ask question about what you asked.
Am I the only one
But
that
you
didn't get that
already,
correct? Okay, I already answered it, have you?
yes.
Okay. Okay, perfect. So now let us divide another class C network into 8 instead of 4. So I've mentioned that if you want to divide it into 8, I think that's going to be a total of 27 bits. We'll be borrowing 3. So if you are borrowing 3, who knows the first IP address? What's going to be the first host address here? Who wants to try? We're dividing this subnet into 8. Who wants to try? You can talk.
Okay, now
Someone.
10.0 point. I think we're using 16 now, right?
Yes. You can use 60.
10.0, 60 loads 32.
This is the first one. This is the first one. So the first one is always going to be .1 here.
.1, I'm sorry. Sorry.
So the first one is always going to be .1. You can see it is now successful and it's giving us a usable IP of 29. Although it's supposed to be, I think that's supposed to be 32. Yeah, that's supposed to be 32. So 29, one is for the network, another one is for the broadcast, and this particular server or this particular configuration takes one for itself for other things it's managing. So that means let's call this class 6A subnet 1. Add. You can see it was successful. If it was not properly configured, it's not going to be successful. And you can see it's giving us 21 available IPs. So if you go to new virtual network, who will tell me the next IP? Who knows the next IP? The next host address, rather.
You call the last national one.
Okay, I'll call you by random. I don't want someone to talk. Daniel, are you with us? I'm just seeing Daniel. By the way, Daniel, how was your exam? I think Anjorin is also writing exam.
Yeah, it's all good, sir.
Okay. Okay, Abiodun, what's the next host address?
10.0.60 point
10.0.60 point. Point what?
then 60
Good
65.
afternoon, sir. I cannot actually see the screen very well, so I'm not really following. I'm still on my way. I'm on the
Okay,
way.
okay, no problem. Don't
Yes.
worry. The video is going to be uploaded to
Uh,
YouTube, so you can watch it there.
all right, sir.
Okay. So Abiodun, I'm with you. 10.0.60.1.
So
65.
that's what I
It's
was
not
saying.
going to be 64. Remember, we're dividing this into 8, not 4. So we are borrowing 3 bits and not
Please,
2
sir,
bits.
can I see the one that
So
was created before so that I'll know what I'm
don't worry,
doing?
Daniel. Don't worry, Daniel. You
All
watch the
right.
videos later. Don't worry.
All right, sir.
So Abiodun, do you want to try again? Okay. And Jerry, do you want to try? What's our next post address?
What is the main IP address working to?
I'm not hearing you.
The school network is kind of body and talking what IP. I need the IP. I don't really see the
You know what?
IP.
Don't worry. We're not really making words of what you're saying. If you're using an headphone, maybe remove it. No, don't worry. Your place is noisy. So we're not noisy
I think
anymore.
it should be 64.
Okay, Abiodun, what's the next one? It says 64.
65. 65. It should be 65.
Now, 65 would go, but 65 is not our immediate next one. The immediate next one is supposed to
33.
be, who knows the,
33.
that was well, it's supposed to be 33. So our immediate is 33, which is class CA subnet 2. Perfect. You see now we have this. So I'm going to allow you guys to understand or take care of the remaining one. So you know what you need to do is just to continue adding the with Samuel.
So I'm sorry, but no, I understand actually, but I still have problem. Okay, so I'm going to send us video on this.
Yes, I'm going to send you a video for that because there's a calculation to you understanding. Oh, okay. What to borrow, because if you just blindly borrow, for example, if you borrow that time when we borrowed 2B for this, if you borrow it and you are now using a calculation of dividing by 5 or dividing by 4 or dividing by 8, it's not going to work. So there's a calculation to that. I can't go through that now. I need to go. But I'll send a video that will explain that in details, or maybe I'll make a video, any of them, later today.
All right.
Okay. Any other question from anyone? By the way, do we understand subnets in now? And how do we get it? How was it? Nobody wants to talk. What's your experience with this whole subnetting class itself? What do you think? By the way, you would see that this particular, this is for the Wi-Fi now. You see that this particular Wi-Fi is on the network of management, network of staff, network of students, network of Crestore. So it means if anything on this Wi-Fi, if anything happens to this particular Wi-Fi or network, it doesn't affect these people here, it doesn't affect these ones here. And you can even have different configuration or Wi-Fi bands for the different systems here and even other security systems. So that's just that. Since nobody has any other thing, comments, question, concerns, let's end today's class here. And I'll guys tomorrow. Samuel.
So okay, just want to ask, like, this subnetting, like, the what is really the point? Because when you're using, I understand that it's different networks actually, but let's say they're under Starlink now. We understand that it's still on that same Starlink network, right? So I mean, if there's a network failure from Starlink, it's going to affect all networks, right?
Okay.
Right. Yeah, the uses the I just want to know the importance of this.
All right. Now, for that, let me show you this. Let me show you. Okay, no, not there. Let me show you a practical example of why that subnetting is important. Look at, so the particular router this system is using has 4 different ports, 4 different LAN ports. Now, on these different LAN ports, you can have these configurations on it in such a way that a switch can carry that port. So, for example, on this port, okay, let me use this one. Let me see. Let me open this port. I know. My network. Come on. I have to join another meeting. Let me reload. I think my network is slow. So, a port in your router can be designated for a particular network in such a way that if anything happens on that network, where you know you have to trigger from or understand anything from is where that port is connected to. So, for example, if there are 5 devices connected to a switch that is on this particular port 2, and there's an issue with one of the devices not connecting or having some issues itself, you know where to check from. Now, that's number 1. Number 2, when it comes to networking, internet is just what is sending your packets outside of your router system. You know, you check. I think there's a video that explained, I think that was the first one that was using Opera, for example, in such a way that if you are communicating within your network, you are just within your infrastructure itself. It does not have anything to do with internet. That is how you send files. That's how you communicate. You can do a lot of things inside the network itself. So if there's something wrong with a network of, say, a network in, I don't know my internet. If there's something wrong with a network in, let's say we have network A, B, C, D. If there's something wrong with network B not connecting to network C, you know the problem is from the gateway of that network. If the problem is from a device A not connecting to device B on the same network, you know the problem is from the IP of that network itself. So the subnetting configuration and all of those things is to ensure that, number 1, your system is not crowded. Because if everybody is on the same network and there are a lot of devices there, you're not subnetting it, you're not doing anything, it's going to slow down that system. So even if you have a very high internet speed, because there are other packets being sent just for communication sake alone, it's going to slow down the network. That's 1. 2, if you've divided it into different subnets, the network will be able to go around. One of the issues affecting us with this Ekiti ICT hub is everybody is on just one single network, and we cannot have a configuration for us to be on multiple networks. If we were on multiple networks in such a way that the student network is different from the cloud computing network, is different from cybersecurity, is different from every other thing, it means that whole system is going to, the internet is going to be reserved better for connectivity instead of some of them being used for communication. So if you notice here now, we're on the default network, if you can see my screen, and everybody is on this class C subnet in such a way that everybody is getting this. So aside from we having limited access to available IPs, because it means on this whole network, we only have 249 available IPs for us to use. Aside, once it is exhausted, no other device can connect it or can connect. But if we have different virtual networks, number 1, it would ensure that our packets are not being sent for just communication sake, broadcast sake alone, because the broadcast is just within a smaller chunk of network compared to being on a larger network. Do you get that?
Yes, sir. Yes, sir. Great.
Okay, so you now understand the benefit of subnetting now, right?
Yes, sir.
Perfect. So, any other question? Questions, comments, feedback? We're not going to come back to networking. I'm not going to come back to networking. In that case, that will be all for today, guys. Ensure to continue watching videos if you know for today. Dara, you want to say something?
No.
Okay. All right. Good night.
Yes, sir.
Thank you.